Radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Sana, I'll be one of your hosts this evening, and I'm joined by Gagan.
Hi.
We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western World, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. Universal time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 to 10 p.m. local Toronto time. Head over to yorku.ca/science/observatory and follow the links to head over to our YouTube page. Just one note that this is a new URL. The university insisted that we replace our old URL with this one, yorku.ca/science/observatory. But all of the important information is still over there, and you'll be able to navigate your way over to our YouTube page to join our OPV chat. We will be monitoring the OPV chat room for questions and showing some archival images from our 1-meter telescope. Unfortunately, we can't be doing any live imaging today. The clouds are too thick and the weather just is not happy in December as usual. For any questions or comments you have about our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. And as always, you can connect with us on Twitter or Instagram at the handle @YorkObservatory or on Facebook at Allan I. Carswell OBS. Well, we have a very exciting show for you tonight, but before we get to that, Gagan, how are you?
Good. How are you?
I'm good. Wishing the skies would clear.
I feel like I haven't seen the sun in days.
Yeah, the clouds are always just too thick, even in the morning. It's really annoying. Like the week or two that people can go observe pretty much whenever because nobody has exams is always the time of year where it's just like not a hope of observing.
Yeah, it's probably the best time of the year as well. And I think this morning I was up really early. I was up at 5:30 and the night sky was clear until 6 a.m. and then the clouds rolled in again. So
oh man, well, this is not going to be too much of a problem for the observatory in the relatively near future because there's this really cool like remote observing system where you can actually set it up that it will just kind of do things by itself. So if you kind of notice that it's going to clear very late at night, like there is a possibility of just sort of, once everything is all fixed up, of just kind of opening it and setting it up to observe and nobody has to be there. So I'm very much looking forward to that because these nights where we go and try and set up and then get home and it's clear when it was cloudy when we were there are always very annoying.
yeah, not fun at all.
I think we've both had our fair share of those nights.
Oh, lots. And all the public tours that we did when it was overcast and everybody asked if we could see through the clouds.
Yes.
I wish, but we don't have an X-ray telescope.
Yeah. I think the most annoying one that I had was a couple months ago. We were doing class support observing for a 4th year class, and they had booked at I think it was 9 o'clock to try and observe their object because that's when it rose. And it was clear before 9 o'clock, and then they join the Zoom link to observe, and it gets cloudy in 10 minutes. We wait around for a while and then eventually give up because it's cloudy and say, okay, we're just going to pack up and leave and you have to reschedule. Right as we're leaving and they've logged off of Zoom and everything is closed, it cleared again.
Oh God.
It was the most annoying thing because if that had happened 10 minutes earlier, we would have been able to observe for them, but never mind. Can't do that now.
No.
Yeah. Well, we do have a lot of, of content to talk about tonight. I definitely wrote way too much. So we should probably get going with our kind of special episode tonight. So Gagan, it's off to you.
Yeah. Well, today we wanted to give you guys a special episode, and it's going to be formatted a little differently than you're usually accustomed to. And that's because almost 1 year ago today, the astronomy world was given possibly the greatest gift ever for the holidays. And to end this year for York Universe, we wanted to give you a full episode about the James Webb Space Telescope, which was launched a year ago today, or no, not today, a year ago on December 25th, which is right around the corner. And since York Universe will be taking the holidays off, today we're going to cover everything about it, what we've learned in the last year, even though most of it we probably heard on York Universe previous episodes. But we just wanted to give you a quick recap, which will just be us fangirling about James Webb for an hour. So, not that long ago, astronomers were pretty limited to observations from the ground. But ground observations present some obvious challenges. We always have light pollution, atmospheric interference. Son and I just had a great little conversation complaining about clouds. You can imagine that these can be pretty frustrating for astronomers, especially around cities. And you can ask any of our observatory crew how we feel about observing right next to a big city like Toronto. The haze of the lights is just not fun. And we always have the football field lights on right next door. So observing at night, especially during the school year, is pretty difficult. And to overcome these challenges, astronomers figured out that putting a telescope in space would solve basically all of these problems. And they were right. But of course, building space telescopes is no easy task. They present many of their own challenges. You know, servicing missions, our space telescopes are really costly, really difficult, and most of the times just impossible. So you usually only have one shot to build and launch the observatory, of course, with a few exceptions, which we'll talk about. But that being said, there were a lot of space telescopes before the popular and currently operational observatories were first launched. The very first ones being the NASA orbiting solar observatories that studied sunspots, which were launched in 1962, way back then, and the Soviet proton telescopes that studied cosmic gamma rays and other high energy particles. And these were launched in 1965. After these two projects, there were a bunch of relatively small projects, and these established observatories in space. However, none were as successful or more widely known than the Hubble Space Telescope, which I'm sure all of you listeners have heard of and are very, you guys, I'm sure, know a lot about this. And this was built by NASA as part of the Great Observatories program, launched in 1990. And it was actually first proposed all the way back in the 60s, although early talks of a space telescope, an American space telescope of this caliber, go back to the 40s. Funding requests for the Hubble didn't begin in earnest until probably about the 70s, and construction continued well into the 80s with an early launch date set for 1983. However, there were a lot of delays, including the massive Challenger disaster, which, as you can imagine, pushed the launch back by quite a few years. And the launch was finally successful in 1990. And the Space Telescope finally went up on April 24th, 1990, but the fun didn't start right away. And it turns out that the mirror wasn't crowned right. And of course, this is a telescope that's orbiting Earth and really hard to get to. And at this point, had to make a decision about whether servicing missions would be worth it. And they decided that yes, they were, because the Hubble was such a huge project. So much money had gone into it. The promise and hopes for this telescope were so great that they decided it would be worth it to fix the telescope. And the repairs weren't crazy. Basically, they had to put a contact lens, kind of like a glasses lens, on the telescope to make sure that it could see correctly, because the first images that came out, really fuzzy, not that great. Maybe OPV can show you some of these, but they weren't what we were hoping for. And so this is what they did over the course of 4 servicing missions until 2005. They tweaked and fixed instruments on the telescope, including the main optical system. And after 2005, the telescope was finally able to provide us with the fully crisp and beautiful pictures that we get from the Hubble now. And I'm sure many of you have seen these all over because NASA releases hundreds of them. And they are some of the nicest pictures, especially colorized, that we've ever seen of different astronomical objects like nebulae, galaxies, clusters, you name it, even planets. You get all of that. So the Hubble wasn't expected to last very long, though. Plans for a successor to the Hubble were brought up, proposed as early as the 80s before Hubble was even launched, because they knew when you end up getting a telescope of this caliber, it's hard to go without it. And the Hubble wasn't really expected to last well into the 2000s. And it was actually a pretty big surprise that it did, and that it's still fully functional right now. So talks for a successor to the Hubble began way back then, especially after the Hubble optics were flawed. Talks about a successor kind of picked up, they ramped up, they became more important, and in 1996 they suggested the next generation space telescope of a mirror that was about 3 times the size of the Hubble Space Telescope, so a more powerful, bigger telescope to take over later. In 2002, the James Webb Space Telescope got renamed, or it, got its name after another 8 years or 6 years, and they reduced the mirror size just to make it a little more feasible. And in 2003, they awarded the contract to build the telescope to Northrop Grumman. So a lot of these things happen in quick succession. Now, you might be wondering, this was basically all set in stone by 2003. We are approaching 2023, and this is only the first year that the telescope has been in operation. And this is because between 2003 and 2022, there were a whole bunch of delays. And these are delays in construction, delays in funding, the cost of the telescope absolutely skyrocketing, as well as the space program at NASA not really getting as much funding as it used to get, and this caused some problems for the development of the James Webb Space Telescope. So the first proposed launch was actually supposed to be in the late 2000s, with launches getting delayed and delayed all the way from 2010 up until 2022. Sorry, I made a mistake earlier. I said that the launch happened in 2022. It happened in 2021. So the launch, it was delayed for all these years. Of course, there was a big recession in 2008, and a whole bunch of other things happened. But one of the main things that caused all these delays is that the proposed destination for the space telescope, its location in space, was supposed to be at an Earth-Sun Lagrange 2 point, which is a stationary Earth orbit point that is pretty far away from the Earth in space, not in orbit around Earth as the Hubble Space Telescope is. And what this means for the James Webb is that there will be no opportunity for servicing missions. They really only had one shot to build this telescope, one shot to do it right. And once it was launched, it was basically a complete Hail Mary. They really couldn't do anything about it once it came back. And especially with all the servicing missions that the Hubble had to go through, the James Webb was a little bit, they were a lot more careful with it, especially because the proposed budget of initially $1 billion ended up growing and growing. And the final cost of the James Webb Space Telescope ended up being $10 billion, and this is US dollars. So for all our Canadian listeners, it's a lot more money than that. So after all these missions, after all the testing and delays, again, another delay which occurred because of the COVID-19 pandemic. The Space Telescope was finally launched on December 25th, 2021. And around this time began a whole, basically a big race to get commission time and observing time on the telescope, which I'm sure Sana can tell us about because she has been highly involved in this process. And pretty soon after that, so it took about 6 months for the telescope to get to it took about a month for the telescope to get to its destination at Earth Sun L2. But it took us a few months after that to get the telescope aligned, calibrated, and just make sure everything was in full working order with all the mirrors unfolded and set up properly, because the James Webb does have an array of mirrors rather than one solid mirror that unfold. And in June, we finally got our first images of the James Webb. And these images are breathtaking. If you haven't had the chance to get to the James Webb Space Telescope images, you should. They're all available online, full resolution, which is an insanely large file, but completely worth it if you can download it. You should absolutely take a look at these images because they blow everything that the Hubble did out of proportion. And I'm sorry to say that to the Hubble because you're my favorite space telescope for so many years, but all the anticipation for the James Webb was worth it. And we were finally able to get these images. And now the James Webb is doing a lot of good science stuff too. They're doing observing on galaxies, exoplanets, and a whole bunch of other things. And it's just been a long time coming. So, yeah, that's the history of the James Webb.
I know what you said about like it blowing Hubble out of the water. Like, I remember after the first image release, the one image, like, I mean, they were all fantastic, but the one image that kind of did it for me was this image of the SMACS 0723, which is a massive galaxy cluster. That was the one that really blew me out of the water because they just kind of went all of a sudden and are like, oh yeah, here's like 4 more of the most distant galaxies that we know of in the universe. And it was like, okay, it took Hubble about 30 years to get to that point. Maybe not 30 years, but it took Hubble a very, very long time to get to that point. And here it is. It just did it in like its first image release. I was really stunned. That's the one thing that I remember about that.
Yeah, so if you guys want to look up SMACS, it's spelled SMACS J0723. There is a photo comparison of the image taken by Hubble and the image taken by the James Webb Space Telescope, and they're identical images taken of the very same part of the sky, and the images have been aligned to scale with each other. It is just astounding the difference between what the Hubble can see and what the Webb can see, because the amount of galaxies there are in this picture, it is unfathomable to me that there are that many galaxies out there. Even to this day, even studying astronomy and, you know, being in astronomy communications for this long, it still baffles me.
Yeah, another thing that is also on, if you go to NASA's website, has a ton of these images, but they actually do show you the spectra of 4 of those really distant galaxies, and that in itself is just it's completely mind-blowing to me that they not only got these fantastic images, but they also got spectra of these things, which is just insane to me.
Yeah.
It's just these things are so unbelievably faint. It's crazy that it was able to do that in like the first image release. And I'll talk a little bit more about the science later on, but it just keeps getting better. Like they just keep releasing more candidates for these distant galaxies and getting spectra of them. It's really a fantastic telescope. And one thing is that if you like looking at these pictures, one thing that you can do is you can actually process them yourself. It's a bit of work because the images don't come out of the telescope looking like they do in the image releases. But if it is something that you like doing, a lot of these images are publicly available either right now or they will be publicly available within the next year. Some of them have proprietary periods of about a year. But they will all eventually be released publicly. So you can go to this Mikulski Archive for Space Telescopes, or MAST, and you can actually download the images and make your own pretty pictures and look for cool things. I know I was showing Gagan some of the images that I got from the collaboration that my supervisor is on, the Canucks collaboration. It stands for the Canadian Nearest Unbiased Cluster Survey. So we get 5 fields with JWST, fairly deep images. And we were I had pulled up some of the images and we just like zoomed all the way in and we're clicking around, and that was a lot of fun. So if you have the chance to do that, I would definitely recommend it, because you just keep looking and going like, what is that? And what's that? And that's so cool.
Oh yeah, we spent like 2 hours just zooming in and looking at the most red objects in that picture. And it's crazy because some of these things are, again, the oldest observed objects in the universe, close to 13 billion years old. And the Webb just was like, oh yeah, here's a picture I took this week. And Hubble was like, oh, it's 2017. I'm so old. Please, this is the last photo I'm going to take before I conk out.
I am genuinely scared every time I see like a news article or something that mentions Hubble, because that telescope, like, it's old and it's kind of running on its last leg. So I'm genuinely worried every time I see a news headline that it's just going to be like, yeah, Hubble had some major emergency again, because it's had a couple in the past few years, and it's put in safe mode while NASA's investigating, and it's just going to be a matter of like a couple weeks before it's announced that they're decommissioning it. And I love Hubble. I love Webb too, but I love Hubble, and will be incredibly sad when that telescope is decommissioned. So I always get scared every time I see Hubble in the news. And I mean, it's still producing great science and great pictures, but still.
Oh no, it has a new baby sibling for the Hubble now. It's the star of the family.
Yeah.
But I mean, the thing is, okay, I'm going to say this in terms of our observatory telescopes. And for all you listeners who haven't heard us talk about the York Observatory telescopes, here's your chance to get a little introduction to all 3 of them. So, it was first built, 2 telescopes were installed in 2 of our domes, which were the 2 domes. There was a 60 centimeter telescope installed and a 30 centimeter telescope installed, both from Competition Associates in Massachusetts. And this was in 1969. Both of them were built in 1968. So relatively new, state-of-the-art at the time of them being built. The 60 centimeter telescope is still around to this day. And this is because it is a great telescope, but the reason it's still around is not because it's a great telescope, but because it is bolted in a concrete beam 4 stories down into the ground, and we cannot move it because it is a 1-ton telescope with a 1-ton counterweight and just incredibly large and old. It's does good science, but it's really cranky. It doesn't like when we touch it at all. So that's the 60 centimeter. The 30 centimeter.
When the wrong people exist in its presence.
That's true. That's true. But I think anybody who's under the age of 50 is like the wrong person. So that's our 60. We love it very much. Like the old cranky grandpa. The 30 centimeter, this was before I got to the observatory, many years before I got to the observatory, but we ended up replacing it in the 90s with a 40 centimeter telescope, so a little upgrade. This was a Meade cast grain, and this telescope served us very well. When I first joined the observatory, it was this 40 centimeter and our beloved 60 centimeter. And the 40 centimeter was like this brand new baby compared to the 60. And I love that thing. It has a paddle, then the buttons only work 50% of the time, but I love that telescope. That telescope, the 40 centimeter, is what the Hubble is to NASA. And the reason for that is because when we got the funding for our new 1 meter telescope, which is a plane wave, the 40 centimeter basically got sent out to the yard, and we have it on the roof of a parking garage under a tarp. And it sounds really bad. It's still a really nice telescope, but I can't imagine not having the 1 meter now. And the 1 meter is the James Webb. So I just had to round out that little analogy. I don't know what the 60 centimeter telescope is. I don't have a good space telescope that I can compare it to, other than it just never likes me when I use it. I like the 40 centimeter. Observing with the 40 centimeter was great, and that's the Hubble, but nothing beats the 1 meter, and that's James Webb.
Yeah, just kind of, I have kind of thought about it, like, what would we have done if something went wrong with Webb? Because there were, in all these like weeks of deployments and everything, there were so many single points of failure where if one thing didn't work properly, like one pin on the sun shield didn't unclip when it was supposed to, then the entire, like, the mission is just done, because you can't use the telescope at all without that working properly. I remember kind of thinking sometimes, like, what are we going to do if something doesn't work? And I would always just get kind of worried about, it's really going to suck, like, going from having the potential to do all of these amazing things to just not being able to do it at all, because there are some things that Hubble just can't do. And Hubble is a really fantastic telescope. I don't want to say anything negative about Hubble, because it's an amazing telescope, but
it is, yeah.
It's just, Webb has just, even in the first, we're only, realistically, it's the first year in space, but it's the first 6 months of science. It is like rewriting what we thought we know about a lot of fields in astronomy. And it's kind of, a lot of those things are kind of details about models, and some details of, we didn't think that certain things could happen, but it turns out that they can, and Webb has shown us that they can. But it's still just, I'm really, really glad that telescope worked. I was stressed for the first month. So there was a joke around the time of the launch of Mars rovers have 7 minutes of terror, because there's a 7 minutes between when it's entering the atmosphere of Mars, that you don't know what's going on. But for astronomers, it's 30 days of terror, because it took 30 days for the deployments and the alignment and everything, and for it to reach orbit in L2. So it really was those 30 days of terror. I was so scared.
Oh yeah, and the other thing is like, it was just so insanely expensive. Like I said, $10 billion. I don't know if, like, for comparison, let me go find the Hubble budget, because the Hubble budget, I think, was much, much less.
Yeah, like, realistically, it would have been disaster for NASA, and probably ESA and CSA as well, if this thing had launched and not worked. It would have been complete disaster.
Yeah.
You justify to taxpayers spending $10 billion on a telescope that didn't work.
Oh yeah.
We can't fix.
The Hubble cost $0.5 billion to build and launch.
Mm-hmm.
Which, in terms of space telescopes, that is kind of to be expected, just because there's so many different aspects that go into the building, testing, launching, that it's just insane. And since it's launched, I didn't realize this, but it's actually cost another $14.5 billion for servicing and just overall functions, including, I guess, personnel who oversee processing and other operations related to the Hubble, which over the course of 32 years, not too bad. I know I'm saying that about $16 billion that I don't have, but for a space telescope, I'll allow it.
Yeah, it's totally worth it for the scientific return of Hubble. As with Webb, every penny I think was worth it.
Yeah, build another one. I'll pay for that with money I don't have. But the James Webb, already racked up 10 billion in just the building and launch, which was more than a lot of people, including NASA and the US government, thought they'd bargained for with the initial $1 billion budget at the time of conception. And for a potential launch in 2007. So they racked up $9 billion in just testing and delays. So finally, it was like in 2016 when the telescope was built and completed. And it was like $10 billion. And then after that, we had 5 years of delays and testing. I get it. I get why they did so much testing. But if it hadn't worked, I think we would never have built a space telescope of that caliber ever again.
Probably not.
I don't think we would have gotten cleared. I'm so glad it did for the sake of current and future scientists.
Yeah. It's actually kind of funny that when you mention the cost overruns, every 10 years, the decadal survey for astronomy is released. There's like a committee of people who go and they look at like the top priorities for astronomy for the next decade in the United States, and they make recommendations for what the United States can do to sort of maintain their place as like a scientific leader, like what telescopes to invest in and things like that. And they did recommend a successor to Webb. I think it's called LUVOIR. It's pretty much Webb, but an optical telescope and significantly larger. So that's still many, many, many years out, but would definitely be another really cool space telescope to get. But they also kind of threw shade at what happened with Webb, and they recommended if you're going to do a space telescope like LUVOIR, you need to put together a committee to look at what happened with the delays and the cost overruns and make sure that doesn't happen again. So I just think it's kind of funny. Like they're absolutely right, but it's kind of funny that this survey committee is saying like this was ridiculous, and it's so ridiculous you need to put together a committee to try and make sure it doesn't happen again.
Yeah, I mean they want to put LUVOIR at L2 as well. And their proposed launch date is 2039, which is pretty ambitious, I want to say, for not only funding, but like they had plans for Webb before Hubble was even launched.
Yeah.
I know that LUVOIR's, it's been conceptualized for a little while, and they want the development to start within the next 8 years. But the size and scope of this telescope, is just so big. Please, if you're at home and you can look up LUVOIR, LUVOIR, this is like the James Webb on steroids, and its diameter is like the Wikipedia page says 8 or 15.1 meters. Wikipedia, that is a huge discrepancy. I just want to say that's like the difference between $10 billion and $20 billion. That is a huge difference. This telescope looks like it could have its own like postal code.
Yeah, because they had proposed like 3 different versions of LUVOIR based off of the mirror size. You know, the 15, what was it, the 15 meter diameter mirror is one that scientists want. But realistically, we're going to get the 8 meter if it goes forward. Nobody's going to want to pay for a 15 meter diameter space telescope.
Like how many segments do we have to unfold for that?
Oh my gosh. I mean, it was what, 18 segments for Webb? It's going to be like 30 at least.
Yeah, that's a lot of hinges that
Yeah.
you're, it's basically, it doesn't even look hexagonal anymore. It's a full circle, basically.
Yeah. Yeah.
Well, yeah, 36 mirror segments.
Oh boy.
So good luck to the team that has to build that.
Yeah.
It's like, okay, the telescope astronomers want versus what the world can afford.
Yeah. Yeah. In some ways, it might actually be easier to make LUVOIR than it was Webb, because one of the other benefits of making a space telescope like Webb is that it required so many new technologies that we now have. So things
Right.
like sun shield and the technology for the mirrors, you have all that technology now, and it actually has applications like outside of just space travel. So this same kind of technology that was used to be able to do this mirror alignment has applications in eye surgery. So
Yeah.
it's like, it's definitely going to be very hard to make something like that, but you, at least this time, you don't have to kind of start from scratch with all of these crazy technologies that you need. You can just kind of build off of that. So the building
Right.
there for a LUVOIR.
Especially. Sorry, go on.
No, it's okay. Good.
Oh yeah, because I was just gonna. It's like it's basically the same as the Webb, just way bigger.
Yeah, which would be
so. Since we've done it once, why don't we push this launch date up 2035? I support it. Let's be ambitious. Let's be even more ambitious.
Yeah, let's petition NASA.
Yeah, I'm gonna take this to the decadal survey right now. I do want to say we are already over time for the first half, which I thought would be our short little period, and I know Sana is dying to talk about the James Webb's galaxies, their observations. So how about Sana, can I go through the reminder super quick?
Yeah, we should probably just do that little thing we say in the middle. So let me just and then we'll go to the reminders. For anyone who's just tuning in, you are listening to York Universe. We are broadcasting live from the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. You're listening to Gagan and myself, Sana, currently discussing the James Webb Space Telescope, and we will be spending the rest of the 20-ish minutes we have discussing James Webb for our special launch anniversary episode for Webb. If you would like to join our online public viewing chat room where we're showing some archival images, head over to our website at the new URL, yorku.ca/science/observatory. You can just follow the links over to our YouTube page and ask any questions you have. You can also connect with us on Twitter or Instagram at the handle @York Observatory, or on Facebook at Allan Carswell Obs. So yes, Gagan, running through the reminders quickly is definitely a good idea.
Okay. So, really quickly, there's no more York Universe this year. I'm very sorry, but today is the last you'll be hearing of us until January 9th, 2023. So we'll see you next year. There are also no more Wednesday night teletubes or in-person tours this year at the York Observatory. So the next teletube will be on January 11th, which is a Wednesday, again, of course. And the next in-person tour will begin on January 18th. As well, we have some cool observing things going on. Sana, take it away.
Yes, so the 21st, a couple days away from now, is the winter solstice. This is the winter solstice is the shortest day of the year, which I am slightly sad about because I'm really loving all these hours of darkness for observing. So I'm sad that we're going to be approaching the shortest. I wish we had a bit more time there. And also the 21st is another important date for the 21st. It is the date of Mercury's greatest elongation. So this is probably the best time to observe Mercury. It's the time where it's furthest away from the sun. Mercury is kind of a tricky planet to observe because it is so close to the sun. So if you do want to take a look at Mercury, this is probably your best bet to do it. It's the furthest distance away, so the safest time that you can observe Mercury all year. And on top of that, if anybody is wanting to do any fun observing, the planets around this time are just amazing. You can see, I think, all of them in one night. If you want to do these observations, I'd recommend starting with Mercury and Venus because they're the closest to the sun, so they move out of our field of view the earliest. Then go on to Saturn because it does set the earliest. And then you have, I think, most of the night for the rest of the planets, including Mars, which is looking really amazing. We got almost all of the planets except for Saturn, Venus, and Mercury in one night the other night with the 1 meter, which was a lot of fun. So we'll hopefully have some great pictures, and if any of you go and observe and get some cool pictures, definitely probably tweet them to us so we can all see amazing planets from you.
Yeah, observing is super fun during the winter, so please take any opportunity that you can get. If the skies are clear, I know we haven't been having great luck with that over in Toronto, but anywhere else in North America, take advantage of the dark skies. It is worth it, if only to see the Orion Nebula through binoculars. Like, please just take that opportunity.
It was fantastic the other night. I took my finder scope out from my telescope, so it's just this really tiny little telescope. I saw a few planets. I saw the Orion Nebula, and I saw, what was it? The Beehive Cluster, all in one night. I got like 5 different objects, which is just fantastic with this teeny little thing in a light polluted area. It was a lot of fun.
Oh yeah, even the day that we did the Messier Marathon last year, or not last year, 2 years ago now, the picture I took of Orion through my phone on the 1 meter through the eyepiece, incredible. One of my favorite images.
Mm-hmm. Yeah, the winter sky is the best in my opinion.
Yeah, those days when we used to sneak a bag of marshmallows into the warm room and then have like a bunch of hot chocolates on the ready, even though we weren't allowed to have a bag of marshmallows permanently in the warm room. It's okay. Dr. Hyde or Paul, if you're listening to this, no, we didn't.
We haven't done that, or at least I haven't done that in a very long time anyways, so.
It's been a while.
Yep. And we promise we won't ever do it again.
I make none of those promises. But Sana, you're welcome to. All right. I know there's galaxies that you want to talk about, Sana.
Yeah, so Webb has, I think, 4 major science goals. Part of them were galaxies, part of them were the early universe, then there was stars and nebulae, and then there were planets. So I went through and I did a bit of a summary of those first 2 science goals that I mentioned, because I am incredibly biased and galaxies are my favorite thing in the universe, and that's kind of all I want to read about. So there has been so many things in these past 6 months that Webb has done to research galaxies and the early universe, but I'm going to kind of limit myself to a couple of very interesting stories, or kind of what I think are my favorite galaxy facts or things that Webb has discovered about galaxies. So these discoveries go all the way back to the first image release. So I had mentioned before that one of the first images that Webb released was of SMACS 0723, that massive galaxy cluster. It also took observations of Stephan's quintet, which was, for fun fact, it was the second thing that was imaged with the 1 meter, or actually the second set of data we got with the 1 meter that would go on to make a pretty picture for the calendar. So the Stephan's quintet has always been one of my favorite objects, and I was really glad when they decided to release that as one of the first images. The quintet itself is a group of these 5 galaxies. 4 of them are gravitationally bound to each other, so they're in this little group and they're interacting. And then there's a 5th one that just so happens to be much closer to us, and it's just sort of by chance that you see it in the same field as these other 4 galaxies that are actually together. So these 2 things is kind of what I'm going to focus on, but there's a ton of other science. Just those 2 data sets have led to so many amazing discoveries. So first off, briefly talking about the Stephan's quintet. So one of the interesting things that it did with Stephan's quintet is it was able to study the centers of the galaxies in the quintet. It turns out that 3 of these galaxies have active black holes. So these black holes are like sucking in material from their surroundings. And as this material is falling in, it starts to heat up because it's sort of dense material. It's rubbing against each other as it's falling in, and it just emits a ton of light. So Webb was able to observe with the mid-infrared instrument MIRI, it was able to observe some of the cores of these galaxies. And it made a really interesting discovery, which is that there are some molecules called polycyclic aromatic hydrocarbons that exist in the cores of these active galaxies. This was definitely a surprise to astronomers because they didn't think that those PAHs, as they're called, could exist in those environments. It's just because there's a lot of radiation and other extreme things happening there that they thought should have destroyed these PAHs, but it turns out that they don't. And this is a very interesting discovery and also possibly problematic in that PAHs are typically used to study how many stars a galaxy is forming. So it's star formation rate, how many stars it forms in a year or in whatever period of time you want. So it is possibly problematic that these things are existing in environments where we don't think they should be, because that could mean that the existence of PAHs in other environments are not as we think they are. Moving on from that and on to the SMACS 0723 observations. It did a couple of different interesting things here. So one of the cool things that came out of the observations of SMACS 0723 and other galaxy clusters eventually that you'll see is that for the first time you can now see this really faint intracluster light that exists in the cores of galaxy clusters. It's called a ICL, and it's pretty much just produced because there are these rogue stars that exist in between the galaxies and clusters that end up emitting light. So this light is coming from only stars and not galaxies, which just kind of gives you an idea of how faint this is. It was pretty hard to see with other telescopes like Hubble, but because Webb is so sensitive, it really doesn't have a problem seeing this light. And you can end up looking and seeing these really extended areas in clusters where there's a ton of intracluster light. So this is definitely a cool thing to observe because it can tell you how galaxy clusters form, and it can also help you study dark matter because you need to study the influence of dark matter on other objects that we can see. So definitely a really cool thing to be able to look at now when we observe galaxy clusters. Another cool discovery from the SMACS 0723 cluster has to do with the discovery of this thing called the sparkler. Now, this object is really cool. I recommend, if you have this image up, go find an image of SMACS 0723, go to the center and just like zoom in pretty much all the way. And you're gonna see these little dots of light just kind of spattered around the core of the galaxy cluster. And it turns out that these are mostly globular clusters. So they're these clusters of very old stars, a ton of stars just sort of packed together. And you can resolve these things individually with Webb. Again, something you couldn't do with Hubble. So this is a super cool thing on its own. But a couple members on the Canucks team that I had mentioned before that I'm a part of, I was not involved with this, but a couple of the people who I know through the collaboration were involved with this. They found this galaxy that was gravitationally lensed. So this is a galaxy in the background of this massive galaxy cluster, and the galaxy cluster is distorting its light. So what you end up seeing is the galaxy itself looks all weird. It's all stretched out from the lensing as it's distorting the light, and it's also magnifying the light. And you end up seeing a bunch of different little points all around this galaxy, and 5 of them have been confirmed to be globular clusters. This is a super cool discovery because we're seeing these clusters as they were 9 billion years ago. So these are possibly the oldest globular clusters ever observed in this SMACS 0723 image. So this is a pretty cool galaxy called the Sparkler. It was a very, very interesting discovery. And okay, because I'm running out of time a little bit here, just one more thing I want to mention on this front is that JWST accidentally discovered a supernova only, I think, a month after it started science activities. Scientists had imaged this galaxy with a very long name that I'm not going to say because it's going to take too much time. But they imaged that galaxy with Webb and then compared images of that galaxy with images taken from the Hubble Space Telescope. And they noticed this point of light that wasn't there in the Hubble images, but it is there in the Webb images. Another interesting thing is that they observed the galaxy sort of periodically over around 5 days, and they found that over time, that point of light is dimming, which both of those factors together indicate that it's a supernova explosion that happened very recently. So this was by complete chance that it found this, and also a really, really cool thing to discover because some of the most important observations you can get of supernova explosions are within that short period of time after the initial explosion. So Webb was able to do that without making any interruptions to its observations. It's such an important thing, actually, that there are these, they're called TOOs. What does that stand for again? Target of opportunity, where if something like a supernova goes off somewhere within our galaxy or in a distant galaxy, which more likely is within a distant galaxy, you can actually interrupt what the telescope is doing and just point it at this other observation because it's so important to get. So it was great that Webb was able to do this without even changing any of its observing schedules. And the very last galaxy point that I'm going to talk about today is the discovery of all of these cool high redshift galaxies that I had kind of been blabbing about before. So this is kind of some of the stuff that I researched, so this is why I'm the most excited about it. But this was something you really couldn't do with the Hubble Space Telescope because, first of all, these galaxies are very dim, and second of all, you can't even see some of them with the Hubble Space Telescope, no matter how hard you try, because they are so red. So these galaxies exist in the early universe within about 1 billion years since the Big Bang. And because the universe is expanding, it's pulling these galaxies away from us very quickly. Their light is redshifted. So it's really pulled from visible wavelengths all the way out into the infrared. And we just can't see the light with Hubble no matter how hard we try. So Webb has done a ton of observations of these things. There have been quite a few papers coming out that are claiming discoveries of galaxies at redshifts greater than 10, which for comparison is within the first 500 million years since the Big Bang. These are some of the very first galaxies to kind of originate in our universe. And not only has Webb been finding those galaxies by taking pictures of them, it's also been doing a lot of spectroscopy. So has far exceeded the work in this area that the Hubble Space Telescope has done in its many years of operations, only within the first 6 months. And there's still a lot more observations to come on this front. A lot of these are also publicly available observations, so you can pull them off of this Mikulski archive for space telescopes and take a look at them. It's super cool, and there'll be a lot more on this front. So it's definitely revolutionizing our view of astronomy, our view of the early universe.
Yeah, I mean, if you ever take a look at one of those Webb deep field pictures, it is astounding how much red there is, and especially when those distant flecks, the super, super dim galaxies, that is just black space in the Hubble deep field. Those specks are all super red, and those galaxies are just so old. It's crazy to see just how far we're seeing with the Webb now.
Mm-hmm. Yeah, it's so exciting, and I'm going to kind of take this opportunity to give another little shout out to the Canucks team. I only very recently joined the Canucks collaboration only a few months ago, and I get to use some of their data. So it's very exciting because I get to just kind of be a very new member and still get all of this amazing web data. It's just awesome. We have already one set of observations, and we're getting the data we have now times 4 in the coming months. The windows for some of our observations are coming up in, well, now basically. So there is also a chance we get more data on Christmas Day. It's a really, I think it's a really, really exciting one of Webb's really exciting programs, because we can find these super distant galaxies in there. And we're looking at galaxy clusters, right? So we can see things like the sparkler and this faint intracluster light, and all of these really crazy gravitationally lensed arcs, which are just awesome. Gravitational lensing is just amazing.
Yeah, if you see the same galaxy on the deep field image twice, don't worry. That's just because it's so far away, it's being lensed around the light of other stars. So while it did freak me out the first time I saw it, to be expected.
It's so cool. There's one galaxy in the things that the data that we have now where you actually see the same source 3 times.
Oh wow, 3.
Yeah, it's really cool. And then there was one also thing that I didn't mention, but Webb has also observed an Einstein ring, which is where you see when the geometry is just right, you end up seeing a galaxy instead of like imaged multiple times. You see it as actually a ring that just goes all the way around the galaxy that's in front of it. So it has observed an Einstein ring, and those things are really cool.
I'm about to look this up right now.
Yeah, hold on. I have it in the show notes somewhere. Where is it?
Hold on. Okay.
Here it is. Yeah, if you search Webb JWST Einstein ring, it should come up. But the galaxy name is like SPT-S J0418394751.8.
Oh yeah, I know that one. No, I'm kidding. That's one of my favorites.
Yeah, the thing is a really long name, but it is a really cool phenomenon. Like, just especially with Webb too, because I mean, you could see. So Hubble really revolutionized a lot of the observations of lensed arcs, because these are things that you really can't see from the ground. You can see like the biggest and the brightest lensing arcs from the ground, but Hubble showed us really that there's a lot of these really thin and kind of dimmer lensing arcs in these clusters. And as amazing as they look with Hubble, they look freaking amazing through Webb. You can see so much detail, and they really do like these wild things sometimes. It goes just beyond Einstein rings or arcs. They do some really crazy stuff sometimes.
Yeah, you can get lost in one of those images for hours and days, especially if you have the processing power, which thankfully Sun's computer at work does, and is a source of much entertainment when there's clouds in the sky. There are clouds in the sky. But yeah, there's so much that Webb can see that Hubble can't, that ground telescopes have no hope of even thinking about, because everything is just so dim and so far away. And, you know, the Webb doesn't have to worry about light pollution. The Webb doesn't have to worry about atmospheric interference. The Webb has definitely no need to worry about clouds. So it has free reign out there to look at whatever it wants to look at, and it will see as far as anybody's ever seen into the universe before.
Mm-hmm. Yeah, it's so cool. I could rant all day about how amazing this telescope is, but people have better things to do than to listen to me go on about this.
I mean, they're here anyways, if they're still here now.
Yeah, after an hour almost of us fangirling about the JWST and how fantastic it is. And there really was like so many more things that we could have talked about, but this was my very biased opinion about James Webb, because I love galaxies.
Yeah, and the thing is, it's worth it. And are we going to stop talking about this? No, we're not.
No, when I do the radio show, the first thing I always look at is, did NASA do any press releases about cool things that Webb did this week? Is usually the first place that I look, because it's done
Probably, yeah.
Things in our solar system, exoplanets, it's really doing everything.
It is.
Yeah.
And unfortunately, we're at the top of the hour, and we will have to wait until January 9th to talk to you more about Webb. Well, everyone, you've been listening to York University Astronomy and Astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Sana and myself, Guggin. Stay tuned because it is Science Night in Canada, and we're following this up with Quarks and Quarks. You can always connect with us on Twitter with the handle at York Universe, and check out our website for show notes, content, updates, and contact info at yorku.ca/science/observatory. That's a new URL, yorku.ca/science/observatory. Thanks for tuning in. Clear skies and have a good night.
Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm radio.
AFM.